Hello all, welcome to my GCP data engineering channel. Okay, in our earlier video we have seen how to create Dataproc cluster and GCP environment. What are the different options available while creating cluster? Okay, we have seen different choices available, select master and worker nodes, and how to set up network configurations and how to set up firewall rules to access Hadoop related web interfaces. Okay, as part of this video, so I would like to show demo on how to create PySpark jobs and how to submit. What are the different options available on Dataproc? Okay. So the intention of this video is to show demo how to create and submit PySpark jobs on Dataproc. So since I am using PySpark as part of this demo, I would like to walk through high level. So what is a PySpark and its features and different applications. Okay. So like Hadoop, Spark also a framework available to process big data, right? So you can process big data, okay, or large data sets and parallel and distributed manner. Okay. So what is a PySpark? Okay. So PySpark is a library, okay, available and written in Python to run our Python applications using Apache Spark, right? Capabilities. Okay. So already Python has very rich libraries to process data, right? So with this PySpark, right, even we have lot more power to process huge data or big data. Okay. So Python plus Spark, it is PySpark. Okay. So then we'll try to see the different features available, right, while using PySpark. Okay. So I don't want to go through each and every feature. So I will go through few important features high level, right? Then we will move on to the demo. Okay. First of all, anyway, it is to process huge amount of data in parallel and distributed fashion, right? And the second thing is, so the Spark has a different capability when you compare with the Hadoop. That is, it is in-memory computation and fault tolerance, right? So we'll try to explain at high level. So in-memory computation means once you read data into RDD, Spark mainly works on the concept called RDD, resilient distributed data. That is a collection of data sets distributed equally, right, across the different node. So RDD is collection of those data sets, right? So this is called resilient distributed data, right? So in-memory computation means once you read data from the actual disk where the data is stored, so in the process, program can doesn't have to go back to the disk every time whenever it would like to refer the data as part of different computation process. This is called in-memory computation. So it doesn't have to switch back to the disk and come back to the processing always. Once it reads the data into RDT, that's it. In memory itself, till the end of the process, it can keep track of the data. Okay. What do you mean by fault tolerant? Right? That means if something goes wrong with the data, Spark knows how to basically recover that from the failure. Right? It has that capability. This is called fault tolerant. Okay. And one more important feature, immutable, right? Immutable means it's a general concept, like once you read data into an RDD, right? So whenever you would like to update the data, right, by applying some transformation, you can't really change that actual RDD. You will have to apply transformation on top of RDD. You have to store that resultant data into some other RDD, right? So the original RDD remains same. You can't directly update that RDD itself. You have to apply the transformation and you can store that resultant data into some other RDD. This is called immutable. Okay, and it also works on the concept called lazy evaluation, right? So what does that mean? Basically, so the data processing is a combination of two things. One is transformation and another one is action. So transformation means you would like to change the existing data into some other format, right? Then you will apply that transformation logic on top of that data. That it just keep that evaluation with it really do, I mean, it will not do that execution till you basically fire some action on top of that RDD. Action means, for example, let's say we would like to basically print top 10 rows or top 2 rows of the data, or else the entire resultant data, right? Or else maximum of that particular data, a minimum of particular. So all this comes under action. The transformation will not be executed till you apply some action on top of RDD. So this is called lazy evaluation. Okay, and also it supports hand SQL. Even PySpark has the capability to apply your transformation using SQL. You can run even SQL queries using PySpark. Okay, and we'll see few applications, right? So by using PySpark, you can even process batch and streaming data, right? So anyway, I already told Python already has data processing libraries available. So with the adding feature of parallel and distributed processing, Spark, so this is widely used across the industry. Okay, and PySpark is very well used in data science and machine learning because Python, you all already know Python has very rich libraries available for machine learning and data science, right? So in such cases, PySpark is very much useful. Okay, these are the few features and applications. Okay, next we'll go to the right uh, to the demo. Before going to the demo, we would like to see what are the different ways or approaches available, how you can submit PySpark jobs on Dataproc cluster. Okay, so the first one is Spark shell. So using, it's an interactive shell, right? So you can submit PySpark related commands and you can work, right, directly using Spark shell. Okay, the second one is you can wrap up PySpark commands related to the job or workload into a Python script, and you can submit that Python script as a Spark job. Okay, this is second option. And third option is through GCP console itself you can submit PySpark job. The fourth one is CLI, command line interface. So as part of this demo, I would like to show first two options. Okay, in upcoming videos I will try to show the remaining options. So as part of this demo, we'll see how we can submit PySpark jobs using Spark shell and also a Python script. Okay, yeah, let us move on to the demo. So this is these are the tasks which we are going to perform as part of our demo. Okay, I will run few PySpark commands using Spark shell one by one. So I would like to group them, the same commands whichever I've been using while working with PySpark shell. I'll be just grouping them into a Python script. Okay, then I'll try to run that Python script using Spark submit command. Okay, these are the few steps which we are doing as part of that demo. The first thing is we are trying to read some data from a text file which is already available in the HDFS, Adobe Distributed File System. So I'll apply some transformation to clean and transform that data as per my requirement. Okay, then I'll group and aggregate the data. Then I'll try to print those results to the console. These are the high level steps. Okay, let us move to the demo. Okay, this is my Dataproc cluster already created. Okay, let me click on this cluster and go to the VM instances. Okay, so this is a master node from where you can interact with the Dataproc cluster, right? It will open up master node VM instance file system. Okay, it's taking some time. Yeah, if you see, I have some data. Okay, if you see this data, right, so it's a simple data. So vehicles sold on each month based on the city. Now what I would like to do as part of my demo, basically I try to read this file and I'll split this each line and I'll try to read the vehicle name and the quantity sold, and then I'll try to group that based on the vehicle name and try to sum the quantity based on the vehicle name, and then I'll print those results. So these are the simple transformation I would like to apply. Okay, yeah, now I would like to perform this task using my Spark interactive shell. For that you will have to type PySpark. This is the command you will have to type, and master node of the Dataproc cluster. Okay, then it will open a interactive PySpark session. Okay, now you can see our Spark session has been opened. With the interactive shell, you don't have to basically code to open a Spark session. So by default, it will open up a Spark session for you. So we will use the Spark context to perform our task as part of this demo. So SC is the Spark context available for you already. Now I would like to use that Spark context to read data into RDD. Okay, for that what I'll do, row. Okay, these are the Spark transformation to read. Okay, right, this is a transformation. I'm trying to read the data available in this path. This is a folder available in the HDFS. This is the file available in the HDFS path. Okay, okay, now we have this row RDD. So now this is the transformation. So as we discussed already, so Spark works in a lazy evaluation model. That means now we have applied the transformation to read data. Now we have data into RDD. Now I would like to fire some action or grant some action on top of this RDD. Take is one such action. That means I would like to print the first row of the RDD. Okay, now you can see the first row of the RDD. This is the first row of the RDD. That means we have this data. That means header we have. Now this is the first row. So that is what it is getting printed with this command. Here this is one, if you try to understand this is one transformation, this is an action. Okay, now I would like to filter the header. That means skip the header. I don't want the header. Right, for that what I can do, header filter row is RDD. Okay, that means RDD is a immutable. You can't directly update this row RDD. Instead you can apply some transformation. You can store that resultant data into some other RDD. Now header is some other RDD. Now I would like to basically store that header into one RDD. Okay, that means now in my header RDD I have the first row of the file, that is header. Okay, now I would like to filter this header from that data and store that resultant data into some other RDD. Okay, now filter, we'll have to write python related lambda function. Okay, it's not equal to, okay, this header is a list. Now I would like to access first element of the header list, that is the header of the actual file. Okay, so I am just trying to filter it out, right? I would like to store the remaining rows of the file except this. That is what I am doing as part of this operation. Okay, so lambda spelling, there's a typo. Now try to first two rows of the, you can see now we don't have header, right? Now in my next step I would like to split each row based on the comma, right? So let me do that. For that I will use map, again lambda, so x split based on comma. Okay, so this is split is a Python functionality to split a string. Now each line will become a string, so I would like to split that line based on my comma. Comma is a separator. Okay, done that. Let me print first two rows. See, now you can see that every line has been splitted, and so each splitted element is now available in the form of list. Okay, so this is some transformation, this is action. So unless you just try to perform some action on top of RDD, this particular transformation will not be executed. That is called lazy use. Okay, now it has been splitted. Now I would like to make a tuple. All right, my final goal of this process is to basically sum the quantity based on my name of the vehicle. Okay, now I would like to just fetch these two columns into a tuple, that is name of the vehicle and the quantity sold of the vehicle. For that again I'll have to apply one more map related transformation. Okay, I'm doing that. Map, again lambda. Okay, so make a tuple, that is x of 0, the first element, and third element, right? This is third element, 0 1 2 third. Okay, right? So now basically I'll have to perform group and sum based on quantity. Now it is in a string representation. To perform that sum, right, I'll have to convert it into a string. For that I'll have to do typecasting, right? Now try to print first two rows of this article, right? You can see now we have a group of tuples where we have a vehicle name and the quantity. Okay, now let me do a group by and sum of this quantity. For that actually, right, I'll have to first import this aggregate function from operator module, right? I have that. Now I can perform group by and then add. So that is what I'm doing. I'm just trying to store that resultant into one more RDD where I'll perform reduce by key and add. Then collect means we'll just collect that entire output into this particular variable or array. Okay, right? So group by symbol and sum. Okay, now I have my resultant data into my OP variable. Now let me print that result in a readable format. What I'm trying to do, I'm just iterating to that object, then printing that symbol name and the sum of the quantity. Okay, this is what the final result. You can see this result, right? Irrespective of the month, just doing group by vehicle and sum of the quantity. So this is how you can interact with the Spark interactive shell. Okay, to exit you will have to type this code, right? Now we came out from the interactive shell. Now what I'll do, I would like to do the stuff using a Python script, right? For that we have this script already available for the demo purpose. Okay, so whatever the steps I have performed as part of my earlier task through Spark interactive shell, I just written them or group them in a single Python script. You see, for that you'll have to import the required Python modules, right? And then I am performing those steps in sequence one by one. So here this is one of the interesting thing. In case of the interactive Spark shell, you don't have to create the session automatically. Spark interactive shell itself creating session for a user, but here you will have to create that explicitly. This is the syntax where you are creating a Spark session. Now your Spark context will be available through that session. Okay, right? The next thing, I'm reading that data into a RTD by using this one, right? This method, and then reading that header into one of the RTD, then filtering that header, then splitting that and reading required column, first column on the quantity column, name of the vehicle and the quantity of the vehicle sold, and then I'm applying group by and then add. Okay, then printing that into console. This is the thing. Now I would like to put this logic into some Python script. Okay, here let me create one Python Spark demo.py. Okay, put that, save it. Now I would like to run this job using Spark submit, then script name. Sorry, there is a typo. Now we'll run that job. Just see the information. See, there is some error. Okay, some issue maybe. Oh, actually this is, we don't have a folder called vehicle, we have a folder called vehicle sold. Okay, I'll have to just modify it. Okay, now remove this folder, remove this file. Let me recreate it with the correct code. Okay, due to the wrong folder name it was giving error. Now it should work properly. This hello spark is getting printed from this line. Okay. See the output. Okay. This is how you can run your PySpark job using script. Okay. Okay, thank you for watching. We will meet in the next video.